Okay, this is the code for Objective 1. The first three sections that we have here, these are all data inputs to properly use the LCD screen attached to the microprocessor. Here we have include servo.h. These are required files for the servo motors. Then here we're basically calling two servos. One of them is going to be motor right, the other one is going to be motor left. Here is where I'm enabling the two pins. So motor right is going to be in pin 41, and motor left is going to be attached to pin 30. Here we're enabling the LCD screen. We're turning the backlight on high. And here we're doing LCD.home. This is basically setting the LCD screen to 0, 0, or column 1, line 1, and we're printing AACC Mechatronics on the top. And here, this is where the most of the code is. It's actually pretty simple. It's very repetitive once you get down to it. So we're doing at the start, the motor right dot right is going to be 55, and motor left dot right is going to be 125. Now both of these values for these two motors, the 55 for the right and the 125 for the left, means that it's going forward at a steady pace. The reason why the two values are different is because the motor left is, or the motor right is backwards the way I have it installed. So the way I have it going, turning properly, it's going to require it to be the value 55, not 125. And then we're setting the cursor to 0, 1, which is column 1 and line 2. And then we're having it print R1V2 moving forward. And we're going to make that last 1,650 milliseconds. Now these numbers did change while I was doing the course, with the battery running out. Slowly but surely I did have to make some changes when it comes to the delays on how long each movement lasted. So after I move forward, it goes, let's see, 90 and 90. When it stops, 90 is the value that you put in for the motor to not move at all. So if you go above 90, the motor goes forward, more and more, and then below 90, the motor will rotate backwards. And then here we have the exact same thing. R1V2 is stopped with a delay of 1 second. Here it is, it turns left. I had it turn left for 0.7 seconds. And I have both of these written at 55. Now the right motor was moving forward, and the left motor is moving backwards. So that's why I gave the left motor the value of 55, so that this would work. Let's see, and I have it stop again, and then again when it moves forward, there's a value of 55 and a value of 125. We'll make it go forward. If I can find a right turn here, when it turns right, both values are 125 each. That's because the left motor is going forward and the motor on the right is going backwards. Again, the reason why 125 is backwards for the right motor is because it was installed backwards. That's about it. All of them are pretty much, it's very repetitive all the way up till the end here. When I have R1V2 is stopped, I have a delay of a really big number, and that's about it.
I would recommend having one forward and one back at the same correct. So at 90 then if 90 is stopped, show a certain number from 90 on either side.
Okay, this is the code for Objective 2 for the Maze Runner robot. This code was a doozy. So we have the same lines here for these 3 patches of code for the LCD screen. This is the same stuff for the motor. We did have a integer for the push button, which equals 2. I had to put a push button in there because it used the push button to navigate through the maze instead of using timing. These here, I have button count, last button state, and button state equals 0. These are all going to be used later on to calculate button counters. Then we have previous milliseconds equals 0, and the time check of 4 seconds. This is going to be used later as well. So the pins, I still have the left and the right motors attached to pin 30 and pin 41. Pin mode 2 input pull up. This is the push button that was applied to pin 2. This is the same, the LCD screen, and we have the AATC mechatronics written on the top of the LCD screen. So for this here, I have the button state equals the digital read for the push button. Button state's going to be changing the value, whether the push button is pressed or not. And here is the if statement that I use to calculate the button presses. So we have like what's going to happen is when the button is pressed, there needs to be a number applied to that. The button presses are going to be determining what the action is going to do, whether it's going to turn left, turn right, stop, whatever. So if the button stays high, the button count is going to be plus plus, and it's only when the button state is actually pressed. The serial.print, this is just something that I was using to track it and just make sure that it was working correctly. And I also put a delay in there just to get rid of the bounce, because if there's no delay, your number's going to, you press it once, but it's going to go like 1, 2, 3, 4, 5. It's going to be really, really fast. Here we have, right from the start, the robot just goes. It just starts off, going forward. And if the button count is 1, or if it hits the wall, what I have it do is I have it stop, wait half a second, I have it back up, stop again, 90 degrees turn to the left, and then stop. This code here, I'm going to go over that last. The button count is 3. It's going to stop, back up, stop again, 180 degrees to the right, and then stop again. And then it's going to set the button count to 4. I forgot to mention that over here. After it's done doing that that action, it's going to increase the button count. So it's going to go from 1 to 2, and then when it hits again, it's going to go from 3 to 4. And then when the button count is 5, it's going to turn off. So these 2 motors are going to be set to 90. The motors won't move, and it's going to last forever. So basically, like what this is just it's a giant equation. So the first line is basically taking a snapshot at a time. The milliseconds, I tried to do some crafty stuff to make it reset, and really this is the only way that I figured out how to do it properly. So the unsigned log, the current milliseconds is going to equal millis. So this value, like the value for here in milliseconds, the current, however many milliseconds it's been, is going to be applied to this variable, this current millis. And the if statement that I have with this is if the current milliseconds is, minus the previous milliseconds is greater than or equal to the time check, it's going to do this. It's going to set the button counter to 0. Now the reason why it subtracted the previous milliseconds is what we have here at the end of a button press. It's going to reset the value. So the reason why we have it set to 0 is because the robot needs to figure out whether it's going in the right direction. So when it hits the first wall, it's going to turn left, and if it's going longer than this time check, which time check for me it was 4 seconds, it could be 5 seconds, it could be 6. But whether it's whether this value of current milliseconds minus the previous milliseconds, if it's less than that, it knows that it went the wrong way because it hit a button again, way too soon. It made a left turn and then hit the wall again, so it'll set the button count to 3 and it'll make a right turn. And of course, when it goes to the end, if this value keeps ending up, being less than 4 seconds, then it knows it hit once, it hit twice, it's the end of the road. So it knew it got to the end of the maze. Okay, so now I'm just going to briefly go over some issues that I had throughout this whole experience. For starters, I don't have much experience when it comes to mechanical assembly. It took me about 3 hours to make the initial robot. When I first finished it, R1V1, I had some gear issues. So there's a ramp, and the gear in the middle, the one connecting the motors, it won't go over the ramp. It's gonna collide with the top of the ramp, and it's not gonna go over. So it took me a while to figure out how to properly get past that, to switch out the gears, so that the gear in the middle is a smaller one, and the gears connected to the tires are the larger, the medium-sized gears. But of course, I couldn't just easily switch them out. There was a bit of a chassis issue as well, because if you put the two bigger gears on the sides, then it's going to be banging up against the chassis. It won't let the gears turn all the way. So I had to modify the chassis a little bit as well. For Objective 1, I didn't really have much issues. The only part of the code that I had to figure out was the motor.write values. Because I was looking at different values, say, motor.write 90. What is 90? What is 155? What does this do? What does that do? So it took me a while to figure out, okay, so 90 is stop. Anything higher than 90, if the motor is in the correct position, is going to be going forward, and anything below 90 is going to be going backwards, if the motor is facing forwards anyway. So with Objective 2, I had quite a few issues. The first one was the button state and button count code. So this code here, if your robot can't track your button states, and if it can't correctly count how much time the button is pressed, then you're dead. You're dead. So it took me a while to properly make the correct if statement for it. I understand, button count plus. I knew that was going to be involved, increase the button count. But it was the, playing with the button state and the last button state, and, playing with all that. And of course the delay as well. I had to make a delay in there, or else, the button count would just go up way too fast when it was pressed. The biggest problem that I had was the timing. And I knew initially what the time code had to do. I knew that, if the button is pressed once, do this, and if the button is pressed twice within a certain amount of time, do this, or else, reset the button count. So the code that I got, I actually found it on a website, and I put it in, and it worked. And I was like, okay, well, why is this working? What is this code doing that I haven't thought of? So I had to break it down, each line piece by piece, and found out what each line is doing. So, okay, so the first one is, unsigned long current millis equals millis. So this is basically taking a snapshot of a time. It's checking the time, how much milliseconds has gone on, since the program has started. And it goes further on and on. I saw the equation, current millis minus previous millis is, you take that value and greater than or equal to time check. Oh, time check. Well, I know what time check is. That's, how much seconds I want it to be, before I decide that the robot is going in the correct distance. Okay, so I understand that value. What are these others two, current and previous? So, okay, well, the current milliseconds is how much how much time has been going on since the program has started. And it's okay, so what's previous? So okay, so further down it says, previous equals current milliseconds. At the end of this, okay, so that's resetting the time. So the previous milliseconds is going to be, if I could explain this correctly, the previous milliseconds would be the value of the current milliseconds from the previous hit. So that's how you make it so that it can properly get a certain time segment based off of how many hits you've done within a certain amount of time. And of course, if that's correct, if the value that you get from the current milliseconds minus the previous is greater than or equal to time check, then you set in the button count to 0. Now setting the button count to 0, I understood that part. It's when you tell that the robot is on its correct path. The last issue that I had was adding the button count plus plus at the end of each code. So at the end of each if statement, because what I did was I didn't have button count plus plus for the first statement for when it stopped and then turned left and go again. And I had the second if statement for the 180 turn. I had that one as button count equals 2, and I was trying to figure out why is it I'm pressing the button and it's not going to 2, it's just staying at 1. I'm like, why are you staying at 1? You should be going to 2, even after it did all of its movements. But instead it just kept doing button count 1. It kept doing stop, back up, turn left, stop, back up, turn left. It was doing that on a loop. So okay, well, how do I get rid of this loop? How do I exit the loop? And I was like, okay, so I'm looking through my notes and I see, okay, when the teacher was explaining the code last time, I wrote down, button count 1, 3, 5. Like, oh, okay, I remember now. I got it. I got to get this out of the loop by forcing it to go to button count 2 without actually pressing the button. So that's why I figured out, okay, so I got to go, button count plus plus, and then have my second action be the button count equals 3, and the final one have the button count equals 5. All in all, the project itself was very challenging, but I had a blast. It was really fun. Making the course at home. My dad watching me learn. It was definitely the most entertaining and enjoyable projects I've ever done at AACC, hands down. Okay, so I have the push button set up, at least the the button counters. I still got to work on the timing, but so far so good. It looks like you're going, hit a wall, back up, turn left, go forward, you're rolling, hit another wall, back up, lane to the right, you're going, third button, you're dead. I got you. Almost done.